Hello, my name is William and this is Nikolai.
Hello.
We're in group 23 and our topic is when to use unsigned arithmetic. So first of all, what is the difference between signed and unsigned numbers? Signed numbers include both positive and negative numbers, whereas unsigned only include positive numbers. In DOX, we use 32 bits to store an integer, both signed and unsigned. For signed numbers, we go from negative 2 to the 32 over 2 to positive 2 to the 32 over 2, take 1. For unsigned, we go from 0 to 2 to the 32, take 1.
Here is a number line to demonstrate how numbers work in DOX. The first one shows unsigned numbers. As you can see, it starts from 0, and in this case, it goes up to 2 to the 8,
take 1,
which is 255, before looping back to 0. Then, for signed numbers, the timeline is split into two. Half of the numbers are negative, strictly less than 0, and the other half are positive, which includes 0. You can see that the positive range for signed numbers is a lot less compared to the positive range for the unsigned numbers.
Another time we would use unsigned arithmetic is for bitwise operations, such as AND and OR. For bitwise operations, the most significant bit doesn't have any special meaning when determining the output. For example, here we'll do the AND operation on two binary numbers. I'll just do it quickly. As you can see, the most significant bit makes no difference. It's just treated like any of the other ones, and we just do the same operations on them.
Now that you know a little bit about unsigned arithmetic, here are some examples to show the difference between unsigned and signed arithmetic. So, assume that we're using 8 bits here, and we want to add 83 to 49. So, unsigned arithmetic, the answer would be which is 132. As you can see, the answer is what we expect. But what happens if we have the same result but we use signed arithmetic instead? Well, the answer will still look the same, but it's no longer 132. The answer would be negative 124. This is because the most significant bit is 1, which indicates that this whole number is negative.
So why is the answer negative 124? Well, firstly, we'll just see what happened in example 1 where we have the unsigned. What happened is we're adding 49 to 83, and the answer is 132. Notice that the maximum here is 255. So the answer fits within a timeline. Now, recall that for signed bits, the maximum number is 127, while the minimum is minus 128. So what happened is we added 49 to 83, and the result is 132. But this cannot be represented in the signed 8-bit numbers. So what happened is the answer got wrapped around to the beginning, and the difference between the maximum and the answer is the difference between the minimum and the answer that we got, which is negative 124. So what happened here is we got overflow, which is what happens when you get a result that you did not expect.
So how do we detect overflows? Well, we can just compare the result to original numbers that we got. For addition, the result that we get should be bigger than both of these numbers originally. This is what happened in example 1, so there's no overflow. In example 2, however, the result is negative and therefore smaller than both of the numbers that we got. Hence, overflow occurred. So, now you hopefully know a bit more about unsigned arithmetic and when to use it. Thank you.